Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic. So today we are covering the topic of K-means clustering. It is the first clustering algorithm that we are covering within this machine learning playlist. So let's get into the details of this and try to understand that how it actually works. So in the simple terms, clustering is the process of grouping similar type of data points together into clusters. Let's say if we have this can be assumed as a cluster and this can be assumed as another cluster, and data points within the same cluster are considered to be very similar with each other, and therefore this clustering technique is used to identify similarities in the data and group them into categories. But let's try to understand in more details that where exactly we need to do clustering for our data. So typically in machine learning, we have two types of problems. First will be supervised and second will be unsupervised. Let's start with supervised machine learning first, and its examples will be regression or classification problems. So we have already been through the lecture of linear regression, logistic regression, support vector machine, k-nearest neighbors. All those machine learning algorithms, whether we are using it for a regression problem or a classification problem, are the examples of a supervised machine learning, where we will be given few features and a target variable as well, and we will show these features and target variable to our machine learning algorithm, and then the algorithm will try to learn a pattern, or it will try to learn the parameters in order to predict the target column. But in case of an unsupervised machine learning problem, you will not be given with any target column. You will be given only unlabeled data. And then your job will be to cluster these data into groups or categories to find the similarities between the data points. And these are the two types of unsupervised machine learning problems. First will be clustering and another will be association based rule that we usually apply with movie recommendation systems or book recommendation system, etc. For the time being, we will keep our focus only on the clustering part. And these are the three types of basic clustering algorithms that you will be supposed to know if you are applying for a job where machine learning is required. And with this lecture, we are covering the first clustering technique, which is K-means. And in the upcoming lectures, we will also cover DB scan and hierarchical clustering. So let's shift our focus back to this figure where we have the data points within these two groups, but we were not given with these groups or clusters. It was created by us. So let's try to understand that how the machine learning algorithm K-means clustering works in order to create these clusters. So I will erase the clusters for now. In order to do the clustering, the first step will be to decide the value of K. This value will decide that how many clusters you want within your data set. And let's say going by this particular data set, visually it makes sense that the value of K as 2 should do the job. Now let's explore further that how the algorithm is doing the cluster exactly. So as a first step, we are done with initializing the value of K. The second step would be to initialize our centroids. So centroids are nothing but it can be considered as the center point for two different clusters, as we have defined the value of K as 2. So let's initialize those clusters randomly at any given point. So I will start one centroid over here, and the other centroid would be, let's say, somewhere over here. And then the next step within this process will be to assign the clusters to these data points. So let's say I will consider the middle point between these two centroids and then consider an imaginary straight line that will help us to assign the clusters. Okay, so let's say that all the data points to the left of this boundary will be assigned to the first cluster, and all the data points to the right side of this boundary will be assigned as second cluster. So we are done with the third step, which was assigning clusters to these data points. Now the fourth step would be to move our centroids. Now how do we move it? All we will do is we will calculate the mean value or the average value from the first cluster, and let's say that value is falling somewhere over here. Okay, so what happens is this centroid now will be moved to this particular point. So now I have moved the centroid successfully. The same will happen for cluster number 2. So we will calculate the average value for, let's say, all of these data points, and let's say the value is falling somewhere over here, right here. So now this centroid from the second cluster will now be moved to this point right here. Done. We have moved the centroid of the second cluster as well. And now going by the new position of these two centroids, we will again try to assign clusters to our data points, and let's say this time we want to use this particular line, this one. Okay, so all the data points to the left will be assigned to cluster 1 this time, and all the data points to the right will be assigned to cluster 2. Again, we will repeat the process of calculating the distance of all the data points within the first cluster, and then we will consider their mean value, and let's say that point is falling somewhere over here. So this is going to be the new position for the centroid of the first cluster. So this centroid is now going to be moved over here. Okay, done. So I have moved the centroid one more time. Similarly, we will calculate the distance of all the data points within the second cluster, and let's say their mean value is now falling at this particular point. So now this centroid is going to be moved right here. Okay, done. So now we have moved the centroid from both the clusters one more time, and now we will repeat the process of assigning cluster to these data points one last time. So again, the middle point between these two centroids will be considered to draw the boundary line like this. All the data points to the left side will be assigned to the first cluster, and rest of the data points on the right side will be assigned to the second cluster. And we repeat this process till the time our centroid is not moving anymore, which means the mean value from the distance that we calculated from all the data points within a given cluster, that mean value point is not changing anymore, and we don't need to move the centroid of our cluster anymore. That is the time when we stop repeating the process and we will be good with the clusters that we have achieved. But there are few questions that you can still have in your mind. First is that how do we choose a proper value of this K? Because although we are good having 2 clusters for this particular data set, but we can also have 3 clusters for the same data set like this, or maybe 4 clusters like this. So how do we come up with a suitable value of K? The second question would be that when we are calculating the distance between all these data points in order to locate the position of our centroid, which method exactly we are using in order to calculate the distance? So we are going to get the answer for all these questions. Just stick to the video. This one is another visual representation that how the clustering actually works. So the image you can see on the left hand side, it is the original unclustered data. All the data points you can see within this data set are there without any label or cluster. And after applying a clustering algorithm like K-means clustering, the data looks something like this over here. So you can see the algorithm has successfully assigned 3 clusters to this entire data set. And this is something that we want to achieve when we are using a clustering machine learning algorithm. And if you have watched the previous lecture on K nearest neighbors or the KNN algorithm, then most probably you are already familiar with these two distance calculating methods. First is Euclidean distance and second being Manhattan distance. These two are the most popular distance measuring methods that we apply in K-means algorithm as well. Where in the case of Euclidean distance, when we are trying to measure the distance between 2 data points like this one and this one, we simply consider the resultant distance between these two coordinates. In contrast, when we are working with Manhattan distance, what we are doing is when calculating the distance between 2 data points like this one and this one, first we calculate the distance by x-axis and then we calculate the distance on y-axis. And after summing up these two values, we finally come up with the result of Manhattan distance. And these are the same distance measuring methods, mostly Euclidean distance, which is applied in K-means clustering as well. When after measuring the distance from all the data points, we are considering an average value in order to move or relocate the centroid for that cluster. So I hope that now you have some idea around how the distance actually is being calculated. Now let's talk around how do we choose the most suitable value for K. And this is where you need to understand about the elbow method. I'll tell you step by step what exactly it is doing. So first we will consider the value of K as 1, which means we are assigning one big cluster to this entire data set. Like this, everything be wrapped within one single cluster. And then considering its centroid, we calculate the distance from each and every data point which is present within this cluster, all of them. And then we square it up. That total value is called as sum of squared distance. Then we consider the value of k as 2, which means to this entire data set we are assigning 2 clusters. Let's say something like this. And we will repeat the same process of calculating the distance from the respective centroid and then squaring it up. And again that value will be plotted over here at this point. And we repeat this process for the value of k as 3 and 4 and 5 up to n. So let's say within this data set, let's imagine that we have only 10 data points, something like this. And when I say that we will try with the value of k up to n, it means the number of data points we have within the data set. What I mean to say is that by the end, all of these data points will be assigned one single cluster like this. And of course, when we do this, then within each and every cluster, the data point and the centroid will fall at the same point, and this is why the sum of square distance will come out to be 0. So this progress will decline to the point 0. Anyways, the point is that we consider the value of k where we can notice an elbow-like structure, something like this. So from this point to second point, the decrease in sum of square distance was too much. Again, from the second to third point, the decrease was lot more. But from this third to fourth point, the decrease was not that much. And same with the next iteration. So now, although the value of sum of square distance is decreasing, but not with that rate the way it was decreasing initially. And by following this elbow method, the point at which we find our elbow will be considered the suitable value of k. So I hope that now you have got a 360-degree idea that why do we need a clustering algorithm, how k-means clustering actually works, how do we choose the value of k, how do we calculate the distances between data points, and the overall concept of k-means clustering. But still I will give you a quick recap. So with k-means clustering, the first step would be to decide the number of clusters, which is nothing but the value of k. There are different methods in order to conclude the best value for k. You can do it visually, you can do it by plotting the elbow graph, and there is another method called silhouette clustering as well. But trust me, most of the times you will be using either a visual approach or the elbow method. The second step would be to initialize our centroids randomly. Third step would be to assign clusters going by those randomly initialized centroids. Then we move the centroids calculating the average value from the distance of all the data points within each cluster. And we repeat this particular process, step 3 and step 4, till the time the centroid is not moving anymore. And that is it. Now let's quickly talk about the advantages of k-means clustering. Of course, it is easy to implement and interpret. The algorithm is computationally faster than hierarchical clustering, and you will get to understand how once we cover the topic of hierarchical clustering. So I would suggest that you please consider pressing the bell icon. You will get notified if I am uploading that lecture. Next is, it performs well with high dimensional data as well. So within this lecture so far, we have seen the clustering happening only on a two-dimensional data, but you can intuitively consider the same thing happening on higher dimension as well. And yes, this works on new data quite well, which not a lot of other machine learning algorithms are capable of. Let's also quickly discover the disadvantages of using this clustering method. The value of k has to be chosen manually, and we have seen that it is a bit tricky and requires some manual effort. It struggles to cluster data of varying size. The algorithm discovers only spherical cluster, which means let's consider a data set where we have clusters looking something like this, more or less something like this. In that case, the algorithm will not be able to do well because the algorithm discovers the clusters in such a way that it performs well discovering only spherical clusters only. And this is why we have the need of other clustering algorithms like DB-scan or hierarchical clustering, which are going to be next topics moving ahead within this playlist. Next is, it can discover arbitrarily shaped and sized clusters, which is again a problem that we will try to solve with another clustering algorithms moving forward. And lastly, centroids can be dragged by outliers, or there could be a possibility of outliers might get their own clusters as well instead of being ignored. So let's consider this particular cluster over here, and we can understand its centroid should be located somewhere right here. And let's assume that it has few outliers over here. Few data points are lying at this position. In that case, the position of the centroid will be moved towards over here due to the increasing distance by the outliers. This is why it is important that you try to get rid of these outliers when you are using K-means clustering. Otherwise, you can go with dbScan clusters, which is very good at handling outliers from your clusters. And the very next lecture within this playlist is going to be based on dbScan clustering. So I hope that you found this session on K-means clustering helpful for you. If yes, then please consider supporting the channel. Do the clicky stuff below, and I will see you in the next lecture with another interesting clustering algorithm. Take care. Thank you for your time.